According to the National Electrical Code, specifically Section 314.23b, when mounting 4 square bracket boxes on metal studs, far side support is required. This requirement ensures the stability and secure attachment of the electrical box, preventing it from becoming dislodged or damaged over time. The purpose of far side support is to distribute the load and prevent the box from twisting or pulling away from the metal stud, especially when wires and devices are installed within the box. This support mechanism is typically achieved using various methods. Firstly, the use of metal straps or brackets that extend from the box to the adjacent stud or framing member. These straps or brackets are securely fastened to both the box and the stud, providing a rigid connection that resists movement. Secondly, another common method involves using specialized box supports that are designed to clamp onto the metal stud on both sides of the box. These supports typically feature adjustable arms or flanges that can be tightened to grip the stud securely, providing a stable platform for the box. Thirdly, in some cases, it may be necessary to install additional framing members or blocking to provide adequate support for the box, especially if the stud spacing is wider than the box mounting brackets can accommodate. This blocking is typically made of wood or metal and is securely fastened to the adjacent studs to create a solid backing for the box. The specific type of far side support required will depend on several factors, including the size and weight of the box, the gauge and spacing of the metal studs, and the type of wiring and devices being installed. It is important to consult the manufacturer's instructions and local building codes to determine the appropriate support method for each application. When installing electrical boxes on metal studs, it is essential to ensure that the boxes are properly aligned and leveled before securing them to the studs. This will help to prevent strain on the wiring and devices and ensure that the finished installation looks professional. Additionally, it is important to use appropriate fasteners such as screws or bolts to attach the box to the studs and the far side support. Fasteners should be of sufficient size and strength to withstand the anticipated loads and vibrations. The NEC 314.23b provides detailed guidelines for the installation of electrical boxes on metal studs, including requirements for box fill, conductor bending space, and grounding. It is important to familiarize yourself with these requirements before beginning any electrical work to ensure that the installation complies with all applicable codes and standards. Failure to provide adequate far side support for electrical boxes on metal studs can result in several problems. Firstly, the box may become loose or dislodged, potentially damaging the wiring and devices. Secondly, the wiring connections may become strained, leading to loose connections or even electrical shorts. Thirdly, the installation may not meet code requirements, resulting in inspection failures and potential safety hazards. In addition to far side support, it is also important to consider the overall design and layout of the electrical system when installing boxes on metal studs. The boxes should be located in accessible locations and should be sized appropriately to accommodate the anticipated wiring and devices. The wiring should be properly routed and secured to prevent damage or strain. Furthermore, it is crucial to adhere to all applicable safety precautions when working with electricity, including disconnecting power to the circuit before beginning any work, wearing appropriate personal protective equipment, and using properly insulated tools. Electrical work can be dangerous, and it is always best to consult with a qualified electrician if you are unsure about any aspect of the installation. The proper installation of electrical boxes on metal studs is essential for ensuring the safety and reliability of the electrical system. By following the requirements of NEC 314.23b and other applicable codes and standards, you can help to prevent electrical hazards and ensure that the installation meets all applicable requirements. When selecting electrical boxes for use with metal studs, it is important to choose boxes that are specifically designed for this application. These boxes typically feature integral mounting brackets or flanges that allow them to be easily attached to the studs. They may also be designed with features such as knockouts or cable clamps to facilitate wiring and cable management. It is also important to consider the size and depth of the box when selecting boxes for metal stud installations. The box should be large enough to accommodate the anticipated wiring and devices, but not so large that it becomes difficult to install or support. The depth of the box should also be considered, as some devices may require deeper boxes than others. When installing electrical boxes on metal studs, it is important to use appropriate tools and techniques to ensure a secure and reliable installation. The tools should be properly sized and in good working condition. The technique should be consistent with industry best practices and applicable codes and standards. For example, when fastening boxes to metal studs, it is important to use screws or bolts that are specifically designed for this purpose. These fasteners typically feature self-tapping threads that allow them to be easily driven into the metal stud without the need for pre-drilling. They should also be of sufficient length and strength to withstand the anticipated loads and vibrations. When routing wiring through metal studs, it is important to protect the wiring from abrasion or damage. This can be accomplished by using grommets or bushings to line the holes in the studs through which the wiring passes. The wiring should also be properly secured to the studs to prevent it from sagging or becoming entangled. Furthermore, when making electrical connections within the box, it is important to use appropriate connectors and techniques to ensure a secure and reliable connection. The connectors should be listed for the intended use and should be properly sized to accommodate the wire gauge. The connections should be made in accordance with the manufacturer's instructions and applicable codes and standards. After the electrical box has been installed and the wiring has been completed, it is important to test the installation to ensure that it is functioning properly and that it meets all applicable requirements. This can be accomplished by using a multimeter or other testing device to check the voltage, current, and continuity of the circuits. Any problems or discrepancies should be corrected before energizing the circuit. Finally, it is important to document the installation, including the location of the boxes, the wiring routes, and the types of devices installed. This documentation will be helpful for future maintenance or repairs. In summary, installing electrical boxes on metal studs requires careful planning, attention to detail, and adherence to applicable codes and standards. By following the guidelines outlined in NEC 314.23b and other relevant resources, you can help to ensure a safe and reliable electrical installation. The NEC provides specific requirements to enhance electrical safety. It is critical to comply with NEC guidelines in Washington State, North Carolina, and other locations. Understanding these regulations ensures installations meet safety standards and prevent potential hazards. Proper installation techniques, along with the correct materials, further contribute to safe and code-compliant electrical systems. Remember, electrical work can be hazardous. Always consult with a qualified electrician if you have any doubts or concerns about the installation. It's far better to be safe than sorry when dealing with electricity. Therefore, adherence to the NEC isn't merely a suggestion, it's a necessity for ensuring the safety and reliability of electrical installations. Ignoring these requirements can lead to serious consequences, including electrical fires, shocks, and even fatalities. So take the time to educate yourself about the NEC and follow its guidelines meticulously. Your safety and the safety of others depend on it. In addition to far-side support, the NEC also addresses other important aspects of electrical box installations, such as box fill calculations, conductor bending space, and grounding requirements. It's essential to understand and comply with all of these requirements to ensure a safe and code-compliant installation. Box fill calculations determine a maximum number of conductors and devices that can be safely installed in an electrical box. Overfilling a box can lead to overheating and potential fire hazards. Conductor bending space refers to the amount of space required to properly bend and route conductors within an electrical box. Insufficient bending space can damage the conductors and make it difficult to make proper connections. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current. Proper grounding is essential for protecting against electrical shock hazards. All of these factors must be carefully considered when installing electrical boxes to ensure a safe and reliable electrical system. Ignoring any of these requirements can have serious consequences. Therefore, it's crucial to take the time to understand the NEC and follow its guidelines meticulously. Furthermore, it's important to remember that the NEC is a minimum standard. In some cases, local building codes may impose additional requirements. It's essential to check with your local building department to ensure that your installation complies with all applicable codes and regulations. By following these guidelines, you can help to ensure a safe and code-compliant electrical installation. Remember, electricity is a powerful force that must be treated with respect. Always consult with a qualified electrician if you have any doubts or concerns about the installation.